Just use that one real down the hall.
Can I get the water after you?
Yes, sir. All right. So this is on, get the yellow packet out, please. Please, please, please. And I think it's page 25, yes?
Actually, can I go buy my chocolate drink? Okay.
Yeah. All right. Let's run through these. It says, recall that f at 2 means to replace the value of n with 2 and work the problem to find f at n. The point n comma f at n would be a location on the graph where n describes the location along the x-axis and f at n is the height of the graph. So we have f at, hey, I put you right there. And you had no idea I brought you a gift. We're on page 25.
Thank you.
You can put it in the 3-ring binder, or you can keep the clip on it. Right behind, anywhere in that 3rd row. All right, so we want f at 5. So I'm going to look at the f at n equation, which is this. And oh, cool. All right. So this 5 goes here. 25, I believe. So that goes there. Agree? And so if you work it out, you get 3, 2 raised to the 5th. 2 to the 5th is 2, 4, 8, 16, 32. 32 times 3 is like 96. So that means that on a graph, 2 comma 96, based on what the directions say. So I feel pretty confident that you could do each of those. I think that you're pretty much right in the game with all of those. Agree? 25, I believe. All right. Yeah. Yeah. All right. So is there any others on 9, 10, 11, or 12 that you need me to go over? You feel pretty comfortable with the process? We good? Yeah. Yes. All right. One at a time.
Okay.
Thank you. So on this, on 13 and 14, we're doing the same thing. We're plugging in 1, 2, 3, 4, 5 to get an output each time. And I think you should be pretty good with that. Agree?
Yes, sir.
And then you realize those make points that we could put on the XY axis, which is called the Cartesian plane. But we could just refer to it as XY axis is fine. So we are going to just flip the page over to where it says Scott's workout. Scott's workout. We are now on page 27. At the very top, it'll say Scott's workout.
Yes, correct.
You got it? Cool. Page, yeah, I'll keep it there.
You say 27
Scott's workout? Page 20.
Listen.
Look for it at the top where it says Scott's workout. You got it? All right, cool. All right. Let me read this out loud first. It says, Scott has decided to add push-ups to his daily exercise routine. Okay. He is keeping track of the number of push-ups he completes each day in the given bar graph. And day 1 showing he completed 3 push-ups. Scott can only do 3 push-ups the first day? Woo-hoo! He's a tough guy, isn't he? All right. We don't know. After 4 days, Scott is certain he can continue his pattern of increasing the number of push-ups he completes each day. Okay, so let's think about this. Let's kind of paraphrase it. Scott thinks that, he does 3 push-ups. And then the next day, he realizes, oh, wait, I can keep increasing my push-ups 2 more each day. Huh. So this little table over here with the blocks, the first day is 3 push-ups. The second day looks like 5 push-ups. Third day looks like 7. Fourth day looks like 9. Feel comfortable with that?
Yeah.
And again, I don't know who this guy is, but I'm telling you, he's not doing a whole lot of push-ups. Yeah, you got that right. 3 sets of. Yeah, baby. All right. So how many could he do in the 5th day? So let's kind of, before we start writing anything down, let's build upon what we have. And then what we're going to do is we're going to have somebody who's going to be a scribe for us. So that means over here, some scribe work might take place, and you can have a partner help you. But we're going to do most of it here, and then whatever we write on that board, then you can translate to your workbook. Okay? Oh, I got to take attendance real quick. So kind of think about that. Discuss amongst yourselves what you think Scott should be doing. I see a phone. How do you see that? It's just, no, I wasn't even talking about Frank's. All right. And here and here.
My dean made me late.
I got you here on time. I don't know what you're talking about. That took.
Yeah, she made me skip 6 periods.
Oh man.
And she burst. We had dinner in her office.
Nice. Okay, so do you understand the routine? First day, 3 push-ups. Second day, 5 push-ups.
Somebody called tomorrow on Snapchat. It's over there, I hear over there. Snapchat.
Oh, okay. Someone put that phone on silent. It's Friday. I don't feel like having your dean have to have your phone for the rest of the day. I don't want to do that. Okay. All right. So let's clear this out. All right. So down here at the bottom, we need to do a few things. So don't write anything down yet. We're just going to kind of discuss this. We want to make a table. We want to make the recursive function. We want to make the explicit function. And these are not the official notes. Okay? The official notes that you should write down is once we know that we have it correct, we're going to put it over there, and then that'll be the official notes. Okay, so talk to me, friends. Let's do a table. First day, he did how many push-ups? 3.
Man, I hear a phone.
Silenced.
I hear a phone.
Come on, guys. Second day, 5. Third day, 7. Fourth day, 9. They wanted us to answer the 5th day. What does the 5th day do? 11. Okay, so today is the phone fiasco. All right, so this is day. This is push-ups. Yes? All right. So somebody tell me something about each of the days. What do you notice just on the top row? Okay, so the day increased 1 day each day, yeah? And then what about the bottom row? How much did the push-ups increase each day? 2. Okay. So, all right. Now, I know I wasn't here yesterday, so you had a day off from me. I'm sorry. I wish I was here. I really do.
Ooh, we had a bad sub. I do not like him.
Hey, she gave you a good report, though.
Give me a good report.
Yeah, you're good. You're solid. All right. So, yeah. Yeah, as long as you take that out of here. All right.
I thought it was one at a time. I might just went out. It's one at a time along. One at a time.
She's good. She's just for her first day. She'll get the routine down. All right. All right. Hey, remember we talked about something the other day. There was two things. There was arithmetic and there was geometric. So does anyone recall how we would be able to decide it was arithmetic versus geometric? Does anyone? Which ones multiply? That's it. So if you, hey, guess this worked. If you multiply or divide, it's going to be geometric. So that means arithmetic would be add or subtract. Okay. So a couple of words that we're going to start getting into using. We're going to call this common difference. And we're going to call this common ratio. I just want to have the words down. And what I will eventually do is we're going to probably post up here on top of the wall some terms so we can refer to them. So arithmetic, if you are adding or subtracting to get to the next term. Geometric means you're going to multiply or divide to get to the next term. Does that make sense? And there's only two that we're going to learn about. And we've already introduced both of them. Arithmetic and geometric. Okay? All right. So let's see. I'm going to erase this and make this a little better. I'm going to make it fancier. I'm going to use my straight edge. Okay. So okay. So let's label this. Let's label it with numbers and label it with a title. So let's start with the x-axis. The x-axis is the horizontal. Agree? So does someone want to tell me, are you going to label the x-axis day or push-ups? Day? Does your neighbor agree that down here is day? If that's day, I'm going to label it 1, 2, 3, 4, 5. Is that okay? So if the x-axis is day, what should the y-axis do? Be labeled based on our table. Push-ups. And then push-ups, we could probably count by ones here as well, don't you think? Because we just have to go up to 11. Okay. Now, me and I haven't done this a whole lot this year. I'm a little rusty on it. Can somebody give me 1 point that you can guarantee right now is going to go on our graph?
Can you do 3 and 2?
So you want to do 3 and 2. Where are you getting 3 and 2 from our table?
From the day number 2 and push-ups we did that day.
So day number 2. So day number 2 is right here, right? So how many push-ups did he do on day number 2? 5. So 2 comma 5. Okay. All right. Can somebody give me another point from our table that we might be able to use, other than Frank? 1 and 3. Uh-oh.
I'm sitting here home.
Can somebody else give me another point that we can go with? 3 and 7. 4, 9.
How we gonna do 5, 11, and 5? I already have. Oh, never mind.
So 4, 9. And the last one. 5 and 11. Okay. So this is an awful lot of information that we've just kind of generated with this. Agree? Like we have a whole lot of information up here. We're representing with a table. We're representing with a graph. Was this arithmetic or geometric? Are we adding or subtracting? Adding and subtracting goes with what? Arithmetic. So this is arithmetic because we are adding or subtracting. Okay? That's where we got here, 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 here. All right. So now let's see if we can discover. Let's see if we can discover a little bit more here. Hey guys, chill. I'm not looking at nobody. Oh, don't look at him. Okay, okay, okay. Enough, enough. Hey. No debates crossed. I'm going through this. H. Don't make me stand in between you. All right. So let's look at something real quick. Yeah. Bathroom or water is fine with me. You got some in here too. All right. All right. So let's talk about something. What is happening here to here? What's happening? And it's also happening here to here, here to here, here to here. What's taking place? It's increasing. So up and down, how many am I counting up each time? 2. Counting up 2 each time. How many am I going over to the right? 1. Okay. So that might mean something, right? You what? No, someone's vaping. It's not me this time. Hey Frank, why are you holding your phone? It goes on my desk. There you go. All right. So does everyone feel comfortable that this is taking place? So it's up and over. So like theoretically, could I go up 2, right 1 up here, or right up 1, up 2, right 2, or up 2, right 1, up 2, right 1? Keep going. Hey, let me ask you something though. Let me ask you something here. Could I do this? What do you think? Can this happen? Can this happen? Can I go rather than going from that point up and right, can I go down and left? You think this could happen? And if so, what would this point be right here? What would this point be right here? What's the point? Not quite the origin. 0, 1. So that point right there is 0, 1. Okay, because we went down 2. We were at 3. We went down 2. And then we went left 1. So if I went down 2, I went down 1, 2, and then I went this way. And realize, did I space these out? The days, did I space those out a little bit further than the push-ups? So I have a question. What does 0, 1 mean? What does 0, 1 mean in the context of this problem? What does 0, 1 mean? 0 days. So, okay. So 0 days. So at day 0, push up. Okay. Frank.
My bad.
0, 1. 0, 1. Think about this. At day 0, there was 1 push-up. So did day 0 exist in this story? So you know what day 0 was? It was, who's the person we're looking at? What's his name? Scott. Okay, Scott's hanging out with his buddies. And his buddy's like, dude, Scott, you can't even do 1 push-up. Because, dude, I can do 1 push-up. And so, like, later that day, Scott's thinking about going, well, I just told my buddies they could do 1 push-up. So Scott goes, oh, okay. And then Scott goes to sleep that night, wakes up the next day and says, I'm going to start a routine. So we want to look at, this first. We want the recursive function. The recursive function, if you remember, we're going to use words. So next equals previous. If I could spell, I'd be an English teacher. I'd be an English teacher if I could do that.
I want to be a science teacher.
Previous.
Some big words.
All right. So this pink is referring to this pink here. All right. So I wanted to make my recursive function. We're just using words now. Next means this. Next. So what do I have to do to get to next? What do I have to do? What math operation? +2. Okay. So that's kind of our recursive function. We're using some words to kind of do it. The next push-ups in this case, we can do 2 more. The next, we do 2 more. The next day, we do 2 more. The next day, we do 2 more. So now comes the time when we have to figure our explicit function. So we're going to say f at n. Okay? We're going to use f at n somehow. And I'm going to try n first. And I know we've been doing this a lot. Okay, if I have this n here, if I plug 1 into n, I get 1. Right? If I take 1 and replace it with this n, I just get 1. Is this 1?
No.
No? What about if I plug 2 in? Does this becomes 2? Is that 2?
No.
3 in, is that a 3?
No.
So we can say comfortably, n is not the equation yet. So we have to build upon that n. All right. So I think we had done something with the common difference. The common difference on that pink line was +2. Agree? So I'm going to put a 2 out in front just to see what happens. I don't know what's going to happen. I don't know. I just don't know. All right, so let's take this equation here, 2n, and I'm going to plug 1 in. So I get 2 times 1. 2 times 1 is 2, and that's 3. 2 times 2 is 4, and that's 5. So that's not working. So there's something else that has to happen here. What has to happen there? I heard it, I think. +1. All right. So I think we might be onto something here. This might be something that might be good. Okay, so if I take 1 and plug it in, I get 2 times 1, which is 2. 2 plus 1, which is 3. And then I'm going to take 2. I'm going to go 2 times 2, which is 4. 4 plus 1, which is 5. All right, plug this 3 in. 2 times 3, which is
6.
plus 1, which is 2 times 4, which is
8.
plus 1.
9.
Okay, I think let's just verify. Plug 5 in. Do you feel comfortable with this equation? Okay, hang on. Hang on. Hang on. Hang on. This is going to be a big leap. Tell 2 people around you this is going to be a big leap.
A little bit of big leap, man.
You ready? You ready? Remember we talked about something up there? Where is it? Where is it? Oh! 0, 1. 0, 1. Let's see if this is going to work. 2 times 0.
0.
0. 0 plus 1. Did it work there?
Ew.
My friends, I think I have an explicit function. All right. I need somebody who feels brave enough to write, to go to that board. I'll give you markers to go to that board and to make that as clean of a version as possible there. You agree? Who would like to go?
I got inspiration. What we got?
You do, Baba.
Inspiration.
Go for it. Hurry. Down the hall. Who wants to be a writer? I'm not the writer. Who's going to write? It's crazy. Is that right? It's crazy? Right?
What?
It's crazy. Who's writing? Who's going there with these markers? Making that clean. We need someone to make it clean. Mine looks like a traffic jam. I need someone to make it look better than that there using that information, please. Well, don't make it look like a traffic jam. Dude, we got a whole bunch of stuff. So you see someone sees that, go, ah! Well, I don't want to see that. I want a meter. So can someone clean that up for me? Yeah, just literally copy it, but things I don't want to see. I don't want to see the pink circles, the purple circles, the green circles, the black circles. I don't want to see that. I just want to see this written out as neat as possible over there with the recursive here, the explicit here, maybe list arithmetic. I just want it all nice and clean so we have some really nice notes to look at. I can't be the only one that can write. You guys have been looking at my chicken scratch for the past 3.5 weeks. And it's not good. And people are like, dude, is that a 3 or a 12? I don't know.
Just throw already.
Half? Okay. I'm going to stand between you and Frank. You don't want any? You want any colors? Okay, you get all 4 colors.
Where? You?
On that board. Yep, please. Thank you.
Where?
Well, that's the graph. So I want to make sure you label the graph. Days, 1, 2, 3, 4, 5. Push-ups, 1 through 12.